One thing I've been learning over this time is astronomers try to keep their studies insular, okay? They try to make their little box of this is astronomy and everything else is, a waste of time, okay? Negative. Stellar evolution includes pneumatics, which is the compressibility of air and air-like substances, of gases. Hydraulics, it has to do with the fluids that the object is comprised of. Acids, bases, redox reactions, oxidation and reduction reactions, and any and all electrical and magnetic phenomenon. Basically, anything electrical or magnetic applies to star evolution. I'm going to talk about Seebeck here quickly, but basically, everything humans know and understand about the stars, or the properties of nature, revolve around stars themselves, being that, stellar evolution is the process of planet formation itself. The Earth is an ancient star. The young stars are bright and shining and have spectrums like the sun, and we see them in the night sky on a clear night. And the intermediate age ones are the gaseous ones like brown dwarfs, Jupiter, Saturn, and the blue dwarfs, which are very evolved and which are new Earths, right at their last stage, Neptune and Uranus. Everything that we understand revolves around those objects. And they're not an insular thing, they're connected. They all are in different stages of their evolution. The solar system, as well, isn't a hereditary family either. It's a evolutionary family, meaning the objects in the solar system all evolved on their own scales of time, and the sun adopted them as it was moving through the galaxy. Meaning they're all different ages, they're all different stages of evolution, and they're not related to the sun whatsoever, except for the fact that they orbit it. So placing importance on these objects because they orbit the sun now, and trying to make a model that explains how they got there now, in their current position, is absolutely outrageous. But anyways, more on that later. Thomas Johann Seebeck, okay? Pretty interesting dude here. He discovered what's called the Seebeck effect. He found out that if a circuit can be made of two different metals, and his two different metals were bismuth and copper. He had bismuth on one side and copper on the other. And as long as they were kept at different temperatures, so say the bismuth was 80 degrees and the copper was 40 degrees, what happened was that it was producing an electrical current. There would be electrical current flowing through the bimetal piece. And he knew this because he had windings of it, and there was a compass that he saw by chance, which needle was going like this all over the place. And obviously if there's an electrical current, it will induce a magnetic field, and that magnetic field was causing the needle of the compass to go back and forth and all over the place. Very important effect, okay? It's a thermoelectric effect, meaning thermo meaning heat, and electric meaning electrical current, so thermoelectric. The opposite of that was Peltier's effect, and we use a lot of his things for Peltier coolers. We use them in, cruise missiles, we use them in refrigerators, we use them all over the place. But the Peltier effect was the opposite of Seebeck. All Peltier did was say, hey, well, what if we just do that in reverse? What if we just take a bimetal sheet and we put electrical current through it? Oh my gosh, that means this side is going to become hotter and this side is going to become colder. It was the exact reverse. So literally he made it to where you could have a piece of metal which would get really hot on one side and really cold on the other because the heat only moves in this direction. That's basically the flow of heat. Cold doesn't flow, heat flows. You should know that by basic thermodynamics. But Peltier effect is very important, and so is the Seebeck effect. Now, I wanted to point this out because earlier I said basically all electrical and magnetic phenomenon can be applied to stars, and this is important because the Peltier effect and Seebeck effect are thermoelectric, meaning they're related to heat and electricity at the same time. Now, what is highly electrical and has a lot of heat coming out of it? You don't have to go too far to figure that out. It's the sun. Okay? The sun has a lot of thermoelectrical events happening on it. And if we could just apply this knowledge to a star, we might be able to explain a lot of phenomenon that we observe in the star. As well as things like anodes, cathodes, battery cells, galvanic cells, redox reactions. That all applies to star evolution. Mind you, they're going to be different because the star is, when it's young, it's very hot and plasmatic. But it would help to apply these kinds of things to it instead of going to Wikipedia or all these, science articles, as they like to call it, and trying to say, well, it's a nuclear reactor and everybody knows that it's fusing matter. Just forget that crap. Try to take basic electrical and thermal properties of nature and things that are actually you can experiment on, and then look at the sun and see if you notice any patterns. Go to YouTube and look up solar granules, how they move. Look up where all the metals are in the sun. Like, are there different layers of the sun that contain different metals? Okay, if that's true, guess what? Maybe you can have like silicon on one side and then, I don't know, a layer of iron right here, and then it will reduce a large electrical current. Will just, boom, it'll pop, and bam, you got a CME or something. You know what I'm saying? But you gotta look at this stuff for real. This book is Scientists and Inventors, and I literally was just looking at Seebeck. See that's the dude right on the bottom. I don't know if you can see that. If you can see Seebeck. But look up all that stuff. Study the crap out of it and apply it to the stellar evolution. It's easy, man. And if you make a discovery, publish the paper on vixra.org and make it to where it's understandable, people can read it, people can comprehend it, and it doesn't have any grammar issues. That's science, bro. It's that easy. Oh yeah, today is April 23rd, 2015.